To start, you have to remember what long division did. I can't simplify 598 divided by 27, mostly because I don't have a number that goes into both. So what I can do is I can say 598 divided by 27, and what you were probably taught was to look for the leading digits and say, how many times can 27 go into 59? And if you weren't sure, you round 27 up to 30, and you round 59 up to 60, and you see, okay, it's probably going to be twice. So what I do is I say 2, and then I multiply 2 times 27 to get 54. Subtract, and I get 58. Then we do the same thing. Well, 58 is not that different from 59. So I multiply by 2, and I get 54, subtract, and I get a remainder of 4. And we would say remainder 4 until later in math we said, no, just kidding. We're going to take this and express it as a mixed number. 22 and 4 divided by this divisor, 4/27. And that was a cleaner way to express it. Then if I wanted to get back to the original number, I would take 27 and I'd multiply it by 22 and 4/27. Well, that meant 27 and times 22 plus 4/27, which then distributes. And we kind of know that. I mean, basically, if I want to multiply this back out, I take this 22 times 27 and I add 4. In other words, quotient times divisor plus remainder. Sorry, that's on my throat. Now let's do polynomials. We're going to do the same exact thing, but with polynomials. When I look at this one, this 2 does not factor into anything, and especially does not factor into something with an x minus 2. But I can still divide it and express this differently. So what I'm going to do is I'm going to say x minus 2 is my divisor, and x to the second minus 4x plus 7 is my dividend. This is useful to know these terms too. This is dividend divided by divisor is equal to quotient. So I actually think this is a little bit easier than the long division you might have done a long time ago. And here's why. What I'm going to do is I'm going to look at the leading term, this x and this x squared. I'm going to ask the question, what would I have to multiply this x by to get that x squared? Well, that's just another x. Now, I'm going to line everything up so that I have this x right here on top of the x that's right there. It has the same degree. Then I'm going to multiply this x by this polynomial. How am I going to do that? Well, I multiply and distribute, so I get x squared minus 2x. Then, like before, I'm going to subtract. Now, I'm going to subtract by changing the signs of the polynomial. Change the sign, and add. It is far easier to do that. Your leading term drops out. We intended that. We made it so that that would happen, so that should always happen. And then I add the next 2, and I get negative 2x. Then we're going to bring down the positive 7 and repeat the thing again. What do I have to multiply this x by to get to that negative 2x? And that would be a negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And we're going to repeat the same thing again, where I subtract by changing the signs, plus, minus, and add. And I get a remainder of 3. So what I can say is a remainder 3, but we're going to do the same thing where we express it as a mixed number. I'm going to do plus 3 over the divisor. 3 over x plus 2. Now, if I wanted to check this, I could say, let's take the x minus 2, the divisor, multiply it by the quotient, and then add the remainder. And if I do that, I should get the dividend. X squared minus 4x plus 4, and then plus 3. And yes, that does check. So let's move on. The basics of division, and this is to remind you guys of the term, is that dividend divided by divisor equals quotient plus remainder over divisor. And if I multiply both sides of this equation by the divisor, I get a second way to express this same idea. Dividend equals quotient times divisor plus remainder. Sometimes we're going to say dividend equals, or even better than that, we're going to say p of x, a polynomial, is equal to q of x times d of x plus r of x. All that means is that these are all polynomials, and we're just using these letters as abbreviations. You may see that a little bit later. So let's move on. Here's a special case of this. We're going to long divide y squared minus 4y minus 21 divided by y minus 7. So check the leading terms again. Y times y would give me y squared. So then I go ahead and multiply y squared minus 7y. Then I change the signs, so minus plus, add, and I get positive 3y. Bring down the negative 21. What do I have to multiply y by to get to 3y? It's a positive 3. Multiply 3y minus 21. Just for kicks, change the signs, minus plus, and I get a 0. Now, what does that mean? I have a remainder 0. That means that this original one could have factored. That y squared minus 4y minus 21 was actually factorable into y minus 7 and y plus 3. And an easier way to divide that would have just been to do this. But this is a way to check to make sure that that works, and to check with large polynomials that might not factor so easily. Now, one of the neat things about math in this case is that this is not truly the same thing as this, unless I say that y could not be equal to 7. Once I say that, because clearly you know the divide by 0 problem, now these two truly are the same thing. You kind of lose the information that y couldn't be 7 if you cross the y minus 7s out. And that becomes a way to plug domain restrictions in without necessarily saying a domain restriction. So that concept will hit a lot more in pre-calc. For what happens when terms are missing, meaning my numerator, it does not have every term present. In essence, that's sort of like the number 1005. I'm missing a hundreds and I'm missing a tens place, but we put zeros in as place markers. So what I'm going to do is I'm going to take this and I'm going to rewrite this as x cubed plus 0x squared plus 0x minus 27. That way I have my 0 terms in, and then if I divide that by x minus 3, you should know that should come out cleanly because the numerator is a difference of cubes, and that factors into x minus 3 and x squared plus 3x plus 9. Review your difference of cubes factoring if you forget that. But moving back to the polynomial, I should now know what this is going to divide into. Now, I'm not going to look at this. Rather, instead, what I'm going to look at is over here. Compare. X times x squared would give me x cubed, so I'm going to put the x squared term here. How do I know to put it there? Well, I know that this is 2 terms, so I'm going to look out 2 terms, and then I know that I want my squares to line up. I kind of like doing that because then I know when I've reached the end and everything looks really clean. X squared times x minus 3 is x cubed minus 3x squared. Change the signs, minus plus, add, and I get 3x squared, and I'm going to bring down the 0x. Repeat. Then I'm going to add 3x, because that's what I would multiply by. 3x squared minus 9x. Change the signs, minus plus, add, and then I have 9x minus 27, and that's going to give me a plus 9, 9x minus 27. Change the signs again, minus plus, and I get 0. So that's the that's the quotient, and let's move on. It says, remember, remainders are okay, and divisors can be larger than 2 terms. So this is sort of new for us. So my numerator, I'm also missing some 0 terms, so I have to stick those in. Y squared cubed plus 0y squared plus 0y plus 4. And I have to divide by, okay, my denominator also needs 0 terms. Y squared plus 0y plus 1. So this divisor is larger than 2 terms, it's 3 terms. How are we going to do this? Well, what do I have to multiply y squared by to get to y cubed? I have to multiply by a y. Since this is 3 terms and 3 terms, we're going to put the y right here, so it lines up with the other linear terms. Y times y squared is y cubed, and plus 0y squared plus a y. Remember to change the signs before you add, minus, minus, minus. So that's going to be 0, that's 0y squared, and minus y. Now, I wrote this 0y squared so I could keep things lined up. I only want to drop one thing out at a time, and it gets too confusing sometimes if I try to do multiple dropouts. I didn't really have to write that, but I'm choosing to because that's going to be the next term that I want to put down. Bring down the plus 4, and now I have 3 terms here, 3 terms here, and let's compare. Clearly, to multiply, in order to get 0y squared, I have to add 0 here. So this is just kind of a step that's going to be a place marker step. 0y squared plus 0y plus 0. If you want to, for kicks, you can change the signs of 0, but that doesn't change anything. And I still have a negative y plus 4. And that's it. That's my remainder, because I've reached the end. So remainders are okay. I'm going to have plus a negative y plus 4 over a y squared plus 0y plus 1. And then as a cleanup, let's just rewrite this. This is going to be y. And you can write this in a bunch of ways. I would say y plus, let's put 4 minus y over y squared plus 1. And that's it. Moving on to the back, what happens when we have only variables? You're going to see this happen. There's no numbers here except for the 6th power. But that's okay. I got to stick my 0 terms in, so I'm going to go y to the 6th plus 0y to the 5th plus 0y to the 4th plus 0y to the 3rd plus 0y squared plus 0y, and then plus b to the 6th. Now, something neat you can do when you've got something like this is now we can actually go and insert the b's in and make the b's become ascending order. B to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, and b. There's a nice little symmetry there. B's decrease, y's increase. Or other way around. Y's decrease, b's increase. And then I got y minus b here. So I'm going to now divide it. Look at the y's. Y to the 5th. I got y to the 6th. Minus y to the 5th b. Change signs. And I get y to the 5th b plus 0y to the 4th b to the 2nd. To multiply by this, I'd have to have y to the 4th and then b. And so that becomes y to the 5th b minus y to the 4th b squared. Change signs, so that becomes minus plus. Let's try to shrink this down. Y to the 4th b squared plus 0y to the 3rd b to the 3rd. This has to be plus. To multiply by y, it'd have to be y to the 3rd b to the, let's see, to multiply by b, y to the 3rd b squared. So then I go y to the 4th b squared minus y to the 3rd b to the 3rd. Once again, change your signs, minus plus. You can see a pattern's happening here, but we're just going to finish it out. 0y squared, b to the 4th. Remember, this is coming right down from there. And so then this is going to be plus y to the 2nd, b to the there's b, and I go, let's see, y to the 2nd b gives me, let's see, that'd be b cubed, my bad. I was having a brain fart there. So y to the second b cubed, and that becomes y to the third b to the third minus y to the third b to the fourth. That's going to be plus minus. Going to get y to the third b to the fourth plus 0y to the, or yb to the fifth. Moving back up here, this is going to become plus yb to the fourth. Then I get room that I know you can't do this, but I can, so I'm going to do it. I'm just going to shrink it up just a little bit. Not so much that it falls off the grid here. Y to the second. Let's see, it's got y to the b to the fourth. Sorry, I messed up here. Those should be squares. Whoop. 0y squared, squared b to the fourth. Let's see, is that right? Y squared b to the third. Yeah. So then that multiplies, gives me y squared b to the fourth minus yb to the fifth. Change my signs. I get yb to the fifth plus b to the sixth. Whew, we're done. One more. Then I just add. I need to have b to the fifth. And then if I multiply that, I get yb to the fifth minus b to the sixth, and it's minus b to the sixth. Change my signs, and I have a remainder of 2b to the sixth. Whew. So plus 2b to the sixth all over y minus b. That was a doozy. Yours on the homework won't be near that long, but I did want to give you one just to see how kind of painful it could be. Just to give you a little preview, we are going to have a faster way to do this in the next lesson. Oh, made another boo-boo. That was supposed to be a minus right there. That's why this is... Okay, I'm good. Minus, which makes this a minus, which makes me have a remainder 0. Because this is supposed to have a remainder 0. That's the fully factored form. Again, we are going to have a far easier way to do ones like this, so just suffer through the few of those that are on the homework, and they aren't 6 powers. They're going to be a little bit smaller, so that's good. Okay, last one. Not last one. Second last one. This is added this year. We had questions on the homework that people had questions on last year, so I wanted to make sure you guys kind of got examples of these. Find k so that when this is divided by x minus 4, the remainder is 0. If I have x cubed minus kx squared minus 27x plus 12, and I divide that by x minus 4, what I come up with should help me. I want to have a remainder 0. So I'm going to keep this problem kind of the way it is and say, what do I have to multiply x by to get to x cubed? That's going to be x squared. I have x cubed minus 4x squared. Change your signs, minus plus. And this is where it starts getting a little tricky, because now to add these two, I want to just say that that is negative k plus 4 times x squared, and then I have minus 27x. So then what do I have to multiply by to get to the negative kx plus 4, or this thing? Well, that's going to be a negative plus a negative k plus 4x. So if I do that, then I get a negative k plus 4x squared, and then I can distribute this, and we get a positive k, or 4k minus 16x. Then I'm going to change my signs. Minus, minus, and I'm going to add. So this negative is going to distribute. Negative 4k plus 16 minus 27x, and then plus 12. We're almost done. It may be helpful to write this negative, or this positive 16 minus 27, and actually subtract it, just make that negative 11, because that's what we're going to do up here. I'm going to say that have to be plus a negative 4k minus 11. And as I multiply that here, I'm going to get negative 4k minus 11 times x, and then minus a 4 times negative 4k minus 11. Then we're going to change signs again. So minus and plus, and we're done. Close to done. This is going to cancel out. That should. But this should be equal to 0. So if I just kind of add that up and say 4 times negative 4k minus 11 plus 12 is equal to 0. I get negative 16k minus 44 plus 12 is equal to 0. Or negative 16k minus 32 is equal to 0. And I should get k is equal to negative 2. Again, we're going to learn a method tomorrow where this is going to be easier, but if you know what you're doing through this process and just can kind of keep your groups straight, and your polynomials straight, and your pieces that need to stay together straight, you'll be okay. Okay, number 8, when this is divided by this, the quotient is this, and the remainder is this. So, I'm going to say 3x squared minus cx plus 3, and I'm going to divide that by x plus 3. Then I need to multiply my leading terms, and I get this. Change your signs, minus minus. So same thing, I have negative c minus 9 times x plus 3. And when I've got that, I'm going to then say, alright, so I'm going to do a plus a negative c minus 9. And I'm going to multiply that by each of these. So I get negative c minus 9 times x plus 3 times negative c minus 9. And change your signs, minus, minus. These cancel. And I can add these up and say 3, that'd be plus 3c plus 27 would have to be equal to my remainder of 54. Or 3c plus 30 equals 54, or c is equal to 8. Now, that gives me c. What about k? Well, it says the quotient is 3x plus k. Well, I know right here that the quotient is 3x plus this, so if I plug c back in, I get 3x plus negative 8 minus 9, or 3x minus 17. If I compare that to 3x plus k, then clearly you can see that k would have to be negative 17.